Hello everyone. Today let's solve the problem number 307, range sum query mutable. You can clearly see here what they have given in the question. Here we have an integer array nums. You can clearly see here we have an integer array nums and we need to handle the multiple queries of the following types. You can clearly see here. So we have an integer array nums and we need to handle multiple queries of the following types. When I say following types, it is update. Here you can clearly see update and this one sum range, right? So we have an integer array nums and we need to handle multiple queries of the following types, nothing but update and sum range, right? In update, they have given here parameters. They have passed the parameters index and val. In the sum range, they have given left and right. So this is fine. In update, what we are doing, we have to update nums of index to val, and in some range of left comma right, whatever they have given here. Here what we have to do, we have to return the sum of elements from index left to right. Okay, this we have to keep in mind. So one thing we have to observe here, you can clearly see num array, the return value is null. We have to always return null. This is the initialization part, right? So let's convert this one. Let's write the code using class instead of making use of methods and functions here. Let's make use of the class. So for now, I just want to keep this in mind basically. So for the initialization, it is always null, and for the update also they have given here return void. Void is nothing but in JavaScript terms we will call this one as null itself, right? So for the update and for the initialization part, the return value is always null. Only for the sum range we have the return value number. They have clearly mentioned here. Just keep this one in mind. So I'll just clean this one and we'll be making use of the class basically. That is the reason I'm asking you to remember this. Only return value of sum range is number, and other two initialization as well as the update, the return value is always null. Just keep this in mind. So we must efficiently support both operations given the constraints, this one update as well as the sum range, right? So nums dot length and number of queries can be up to 30,000. They have given here, right? So nums dot length and number of queries can be up to 30,000. We can make use of the brute force approach, iterating over the range, but that will lead to TLE, right? So we can make use of the brute force approach, iterating over the range every time, right? So that could lead to TLE. Better let's go with this one segment tree for this particular problem. Let's solve using this one segment tree. So here let's come to example 1 here first. So here you can clearly see num array, sum range they have given here, update and sum range. This is nothing but the array of integers, array of nums, right? So this one num array of 135, num array is nothing but the, here you can clearly see the initialization part, right? So num array of 135, it doesn't return anything, so we'll be having null. Let's stop here. So here it will be null. This is fine. Sum range of 0, 2 they have given here. What is sum range of 0, 2? Just give me a second here. Sum range of 0, 2 means we have to find the this one. We need the sum from the range 0 to 2. This is 0th index, this is first index, and this is the second index, right? 0 to 2 means we have to add all these numbers, right? In the nums array we have 135 now. So sum range of 0, 2 means we have to add 1 plus 3 plus 5, nothing but here in this case 9, right? So that's what they have given here. That is how we got here in the second place, we got 9. I hope this is clear. Next is 1, 2, update of 1, 2 we are considering. It means in the first index, indexing starts from 0. In the first index, we have to replace the value by 2. We have 3 in the first index. You can clearly see 0, 1, 2. So first index is having 3. We have to replace 3 by 2. That's what they have given here, right? So when we replace 0 by 2 here, it will become 1, 2, 5. Instead of 135, now the nums array contains 1, 2 and 5. So now again they have given some range of 0, 2. Here still it will be null because update operation returns null here. You can clearly see the return value of the update operation is null. So this one will be null. This is fine. Now the nums array consists of 1, 2 and this one 1, 2 and 5, right? So here you can clearly see 0 comma 2 they have given here, 0 to 2 they have given. Some range of 0 comma 2 means we have to add this one, 1 plus 2 plus 5, nothing but 5 plus 2 is 7, 7 plus 1 is 8. So this is how we got the output here. So how can we solve this? As I have already said, let's make use of the segment tree, as we are dealing with the range, right? Range queries we are dealing with. So we are going with, we have to deal with update as well as this one, some range, right? These two. So let's go with the segment tree. So initially, let's go with the approach. Let's discuss the approach, then followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. As usual, let's discuss the approach first. Let's discuss the approach step by step. First thing, I have considered the same question. I mean, same this one they have given in the question, same first example that they have given in the question, right? So I hope this is clear. The output that we need to get here is null, 9, null and 8. We saw this one, right? So we have already discussed this one. Let's discuss the approach step by step. As I have said, just keep this in mind. We are going with the segment tree, right? So just keep this in mind. The approach that we are going with is segment tree. Let's come to the step 1. So first let's build the segment tree here. So we have 1 comma 3 comma 5. If you remember here, let me come here. We have num array of 1 comma 3 comma 5 here. You can clearly see here. So step by step, each parent here, you can clearly see each parent stores the sum of its child nodes 1, 3, 4, 5 and finally 9. How we got this one? 1 plus 3 is 4, this one, and 4 plus 5 is 9. That's what they have given here. Each parent stores the sum of its child nodes. So we have successfully built the segment tree. Now I hope the step 1 is completely clear. So each parent stores the sum of its child nodes. This is the step 1. Let's come to the step 2 here. So here query some range of 0 comma 2. Here you can clearly see we have to find some range of 0 comma 2. I'll just come here. This one we are considering some range of 0 to 2. So we already have discussed this one. 0 to 2 means this is 0th index, this is first index, and this is second index. Some range of 0 comma 2 means we have to add this one entirely from, we need the sum from 0 to 2, right? From the index 0 to index 2. So this will be in this case 1 plus 3 plus 5. Nothing but in this case 5 plus 3, 8, 9. In this case it is 9, right? I hope this is completely clear. So the segment tree gives this one an big O of logarithmic n time, right? That is the reason we'll be making use of the segment tree mainly, right? So the segment tree gives this an big O of logarithmic n times, some range of 0 comma 2. I hope the step 2 is completely clear. Now let's come to step 3. So they have given here update of 1 comma 2. When I say update of 1 comma 2, we have to update the first index by 2, or we have to update the first index or replace the first index by the value 2, right? I hope this is clear. Let's come here. So in the first index 0, 1, 2, in the first index we have 3. We will replace this one by 2, right? So when we replace this one by 2, we get 1, 2, 5, right? We get 1, 2, 5 instead of 1, 3, 5. So we are changing nums of 1 to 2 and nums becomes 1, 2, 5. So updated segment tree here you can clearly see. Instead here we were having, let me come to the step 1 here, 1, 3, 4, 5, 9, right? Here we are having 1, 2, 3, 5, 8. 1 plus 2 is nothing but 3 here, and 3 plus 5 is nothing but 8 here. We know that one thing from the step 2, every parent stores the sum of its child nodes. I hope this is completely clear. So here they have given only the affected nodes are changed here. You can clearly see affected nodes. This one 2 we have updated, 3 plus 5 finally same thing 8. Instead of 9 we get 8 in this case. So we have successfully updated this one index 1 by 2 and now the sum is 8 instead of 9, right? So here queries sum range of 0 comma 2 we have got. So instead of this one array, in the array, instead of 135 we have 1 2 5. This is 0 index, this is first index, and this is second index. Now if we add this one, sorry, just give me a second here. 1 plus 2 plus 5, this will be 5 plus 2 7, 7 plus 1, this will be 8. I hope this is clear. So this is how we got the output. So here you can clearly see, in the step 1 what we did, we successfully built the segment tree. So return value initially, we went with this one, right? Num array of this one 135, return value is null initially, so we have got null here. This is fine. So second step, let me come to the second step here. Query sum range of 0 comma 2 here. Query sum range of 0 comma 2, we got 9 here, we got 9 here, same thing. So this works correctly. And update 1 comma 2, so here we have got this one 1 comma 2 comma 5, still the output will be null here. Why output is null here? Because the return value of the update, this one, so let me come here, return value of the update is null, so we have to return null in this case. So output here is null. So the last thing here, we got 8 here. Let's check the same thing here. So here query sum range of 0 comma 2, after updating the index 1 we got this one 1 plus 2 plus 5, nothing but 8 here. So this approach works absolutely correct. Segment tree, this works absolutely correct, right? So let's discuss the edge cases step by step, and then finally write the code and discuss the complexities of the code that we have written. First edge case here is single element array. I have considered only one element. You can clearly see here. Now I'll just give here some range of 0 comma 0 in this case, right? Some range of 0 comma 0 5 we can consider. Update of let's update 0 this one index by 3, right? So now some range of 0 comma 0, this one, if we consider some range of 0 comma 0 will be 3 in this case. So I hope this is completely clear. This is for the single element array, right? So next let's move on with the second edge case. Nothing but all elements are same. When I say all elements are same, we are considering all the elements same. In this case we have considered 2, right? 4 times, sorry. So let me consider here some range of 1 comma 3 here. This one is 6, and update of let's update the second index by 4 here. This is fine. Then some range of 1 comma 3. Now if we consider this one, some range of 1 to 3 here, means 0 1 1 to 3 we are considering. After updating, this becomes 4 actually, right? 2 plus 4 plus 2, 4 plus 2 plus 2 is 2 plus 4 plus 2 is nothing but 8 here in this case, right? So I hope this is clear. This is for the condition all the elements are same. Next, finally, let's discuss the final edge case or the third edge case here, large numbers. When I say large numbers, this is just the boundary test. So I'll just consider in this case input nums of 100 minus 100, 100 again minus 100. I hope this is clear. So we will just give, in this case we will handle negative, we have to handle the negative numbers and large values correctly. In this case I will not be giving the output. It has to handle negative numbers and large values correctly. It has to handle the negative numbers and the large values correctly. I hope this is completely clear, right? So these are the three edge cases that we consider. First one was for the single element array, second one was for the all elements are same, and third one was for large numbers. I hope all the edge cases are clear. Now let's start writing the code. So let's start writing the code here. We have initialization part, we have update part, and we have sum range part. Again I'm telling, only the return value of sum range is number. So the return value of update and num array will be this one, void or null in case of JavaScript, in terms of JavaScript, right? So let me clean this one. We'll make use of class instead of this one. What do you call? Function with the prototype or methods, right? So I'll just give here class num array. So I'll just give here for the initialization we will consider constructor instead of num array. So I'll just give here nums. So let's write the code later after building the segment tree. Initially let's just do the same thing using class, right? So I'll just give here index comma val. So this is for the update function. We had update and one more function was this one, sum range, right? Sum range, we had the this one left and right as parameters. So I'll just do the same thing here. I hope this is clear. So initially what we have to do, let's build the segment tree. We have discussed how to build the segment tree and all, right? So let's build the segment tree, then let's write the code for this one, initialization, update, as well as the sum range, right? So let me do one thing here. Just give me a second here. In the let's write this one initially. This one we are just initializing segment tree here, right? I'll just give here this dot segment tree equals new segment tree of nums, right? So nums array they have given. So I'm just passing nums here. So I hope this is clear. So for update and sum range, we have to build the segment tree. Then we can make use of that one in the main function or the function within the class num array, right? So let's build the segment tree quickly. So I'll just give here class segment tree here. Let's go with the constructor for initialization. Let's pass the array here. First step is we have to store the length of the input array. So for this, I'll just give this dot n equals length of the array. Nothing but we are initializing n to length of the array, right? So what did I do here? Double semicolon. This is fine. Next step is we need the segment tree array as well, right? So this dot tree equals segment tree array. This has to be 2 into n, or we have considered class, right? I have to give here this dot n, and initially let's fill the array with 0 by making use of fill keyword. I hope this is clear. Next, let's build the segment tree. So for building, I'll just make use of build of array. We have not written the build function yet. I'll just give here this dot build of array. Let's write the build. As we have made use of the build and initialization, let's initially write the build function. So build of array, let me consider here. For build purpose, I'll just make use of the simple for loop here. For let I equals 0, I less than n, in this case class, so this dot n, I plus plus, incrementing the I. So we have to place the input elements in the leaf nodes. If you remember in the approach, we have to place all the input elements in the leaf nodes, right? So that's what we are doing here. So I'll just consider here this dot tree, this dot n plus iteration. This is fine. This is equals array of I, iterated value of the array. I hope this is clear. Next step is here. Did I miss something here? Just give me a second here. So yeah, after placing the input elements in the leaf node, we have to build tree from the bottom up, right? So we are going bottom up, not this one, top to bottom. If you would have observed in the approach, we went bottom up, right? So we have to build the tree from bottom up. I'll just consider the for loop again for this. Let's write this one quickly. So let I equals n minus 1, I greater than 0, and I minus minus. This is fine. Here we have to build a tree from bottom up, right? So iterated value of the tree equals, I can just give here I into 2, because 2 leaf nodes we have, plus this dot tree of I into 2 plus 1 in this case. I hope this is clear. We are just building the tree from bottom up. So I hope this is clear. This is it for the build function, right? So we have successfully written the build function here, right? Next, let's go with update as well as the query, right? So we have to go with update and query. So let's quickly write the update function here. So I'll just make use of update here. Update of, let me pass here index comma value. So this will be here update of index comma value I have given. Initially what we have to do, we have to convert the index to leaf position. So we have to, at any cost, we have to convert the index to leaf position in the segment tree, right? How can I write that one, or how can I articulate that one in the form of code? I'll just give here index equals index plus n, nothing but this dot n here in this case. And next step, let's update the leaf node value every time. So to update the leaf node value, so I'll just give here this dot true of index equals value. So I hope this is clear. So the next step is simple while, let's write the, so index greater than 1. Index has to be greater than 1. So I'm just considering this one in the while loop. So while index greater than 1, we have to move to the parent node every time. So index equals math.floor, or you can consider double tilde operator as well in this case. So I'll just consider math.floor index by 2. So index by 2. This is fine. So we are just moving to the parent node here. So after moving to the parent node, we have to recalculate the sum. So the same thing, I'll just copy paste this one. The line number 14, whatever we have written here, right? So I'll just come here. Let me copy paste over here. Nothing but the this dot tree of, instead of I, we have considered here within the update, we have considered index, right? We are not going with I. So let me make this one index. This dot tree of index. This dot tree of, instead of I, again here index into 2 plus this dot tree of index here, again index. We just have to change from I to index here, index into 2 plus 1. We are just recalculating the sum in this case in the within the update. And again, we know that the return value of the update is null, right? So this is it for the what do you call this one, update function. Next, the final one, let's write the query function quickly. So we'll be making use of binary search here, right? So I'll just give here query of left comma n. So this is the reason we are making use of binary search and we are going with the segment tree. So the time complexity would be big of logarithmic n instead of the this one brute force. It can be big of n square or n cube, right? So in instead of that, we can find this one. We can query the sum with an logarithmic n, right? So this is the reason mainly we make use of the segment tree. So left comma right, let me give here. So initially what I'll do, let's initialize the sum to 0. Within the query, what we have to do, we have to sum up, right? Until from a particular index to particular index. From query means if they have given 0, 2 here in this case, so they have given 0, 2, we have to add from 0th index to second index, 1 plus 3 plus 5. That's what, for that one we have to articulate whatever we have discussed in the upper, that one we have to articulate in the form of code, right? So I'll just give here sum equals 0. Next step is we have to convert the left index to the segment tree position. So I'll just give here left equals left plus n. So in our case, this dot n, as we are going with class, dealing with class. So right equals right plus n plus 1, this dot n plus 1. I hope this is clear. Next step, let's quickly write the while loop, and we know this, if left is odd, then it is a right child. If right is odd, then it is a left child. So let me quickly write here while loop, while left binary search, left less than right here, this one, when left is odd, what we have to do, it is right child. when left is this one odd, yeah, when left is odd, it is right child. I can articulate this in the form of code in this way: sum equals sum plus this dot tree of left. I hope this is clear. Next step is we have to move right. When I say we have to move right, nothing but increment the left. This is fine. One more step, one more thing, we have written the code for when if left is odd, it is a right child, this one. When right is odd, it is a left child. For that one also we have to write, right? So I'll just copy the same thing here. Let me change the necessary things here. So I'll just give here, instead of left, let me make this one to right. Right module 2 equals 1. Let's instead of this one, so I'll just cut this one. Let me give here, let's decrement the right, and sum equals sum plus this dot tree of right here in this case. So let me make this one right. I hope this is completely clear. Next step, we have to move to the parent level after the node, right? After the children, we have to move to the parent level. So let me come out of this one. Left equals, so here this will be math dot floor of left by 2, and for the right also we have to move to the parent level, right? We have to write for left and right, same thing. So I'll just give here math dot floor of right by 2. So I'll just give here right by 2 in this case. I hope this is clear. The final step is we have to return the sum in particular range, left and right, that they have given here, 0, 2 here. We have to return the range, return the sum in the range left, right, this one, if you consider, right? So finally, let's return the sum here. Here itself, return sum. I hope this is completely clear. Let me format the code once. We have successfully built the this one segment tree. Now let's come to the main function here, or let's come to the class here. So we have already initialized the segment tree within the constructor. Let's we have the update here. For the update function, update, we can use update here, and we have the query for the sum range here. You can clearly see query for calculating the sum. So let's make use of these functions here: query within the sum range and update for the update. Initially, let's make use of the update here. So let me quickly give here we have to call the update on segment tree. So here this is simple, code will be simple here. This dot segment tree, I have considered this one, right? Segment tree dot update this one here. This is coming from here, update this one. We have to update the segment tree here, right? Update of index, value. I'm just passing the parameters here for the update. So return value is still null for the update, this one, index and value, passing the same parameters over here. So this is it for the update. For the sum range, we are making use of the query. Let me copy this one, query. So here this will be return. In this case, return value is null, so we are not returning, we don't have to return anything. Initialization return value is null, so we don't have to return anything. In this case, the return value is the sum, right? So we have to return this one. We have to return the sum. In this case, we'll make use of the query, as I've said, this dot segment tree dot, let me paste here query. We are making use of the query function, this one again, this one, right? So here query of parameters. What are the parameters we have here? So left and right. Let me copy the same thing over here. Let me copy this one and paste it over here, left, right. I hope this is clear. This is it. Let me format the code once and let me hit the run button. So I hope this works. Let's see. What's the problem? Value is not defined. In the line number 56, index, value. So here we have val. Okay, let's make this one val, right? This one I considered, I think. Yeah, here index and value, this one I considered. I forgot to change here. So this dot segment tree. Oh, here update, I have misspelled the update here. Up 8 it has become here. Let me add D here. This is fine. Let me run the code again. I hope this works now. So yeah, you can clearly see the sample test case is getting passed here. Let me quickly hit the submit button. I hope this works, man. So you can clearly see all the 16 test cases are getting passed here, man. All the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is segment tree. We know that one. So what would be the time complexity here? The overall time complexity would be big O of logarithmic n. We have already discussed this one for the query, right? So while finding the query, while finding the sum, this segment tree gives an gives the sum in big of logarithmic n time. So that's what we had discussed. So for both update and sum range queries, the overall time complexity would be big O of logarithmic n. That is the reason we are making use of segment tree, right? So what will be the space complexity here? The overall space complexity would be big O of n. Why it is big O of n here? Because we have to store the segment tree. Initially, you can clearly see here array.length. So we have sorry, this one we have to store the segment tree. For storing the segment tree, it takes big of n space, right? So overall space complexity would be here big of n. So the time complexity would be big of logarithmic n for update as well as the query function. So overall, let's consider this one as big of logarithmic n itself, and overall space complexity would be big of n just for storing the segment tree, right? I hope this is completely clear. Whatever the code that we have written or whatever the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.